everyone. Today we will be transforming absolute value function from the parent graph given the vertex form. So we have a vertex form right here. We also have a parent graph of the absolute value function. So what are we going to do is we are going to come up with another graph that would fit to this equation over here. So we're going to be using the concept of h and k. We remember that the h tells us where to move the graph left or right. And then the k is the variable that will tell us where to move the graph up or down. So that means if the h is negative, it's left. If h is positive, it's going to go to the right. If k is positive, it's going to go up. If k is negative, it's going to go down. And then the a that we're going to have in all of the examples that we're going to have today, we will have all a's with 1. So positive 1 or negative 1. There is another video that talks about transforming in such a way that the a is not equal to 1. But for this video, we're going to have a is equal to positive or negative 1. So a here refers to the stretch factor. So if a is positive, the graph is going to opens up. If a is negative, then the graph is going to open down. And then the other name for this hk, this hk actually represents the vertex, or others call it as the locator point. Okay, so let's go over the example that we have here. So again, our target is to transform this graph. We either move left or right, up or down, depending on the equation. And then what I did is I have here a wax paper. I actually draw the parent graph here, and so that we can move it around. Now there is what we're doing right now is the paper version of moving the graph around, up, down, left, or right. But there is also a digital version of transforming absolute value function. I will put the link of that video in the description box below. So in this problem here, before we are able to move this parent graph around, we need to determine where do we go from the equation, left or right, up or down. So from here, we can say that in this equation right here, we can actually rewrite this to be negative of the absolute value of x. Remember, it's h minus k. So this should have been minus is the operation. And then this one was actually negative 2. So that if we have a negative and a negative, it came out to be positive. So, and then we get a plus 3 after that. So what this is trying to tell us is that our h is negative 2. So that is our h. Since it is negative, it's telling us that we're moving to the left. And so this is telling us that we are moving to the left. And then the k here is positive 3. This is telling us that we are moving up 3. So this is up. And then the a at the beginning is it's negative, so it's telling us this opens. So the negative a right here, this is telling us that it opens down. Okay, so but I will give you a trick on how to find for the h. So the h is the sign of the h is actually the we take the opposite of this one. So if this is a x plus 2, so then the h is a negative 2. So that is the fastest way to determine the h or the value of the h. But then you can show the work like this as well. That would be good. Okay, but again, the trick is just to switch the sign. Okay, so from here, I'm gonna move 2 places to the left. So that would be 1 and 2. So I already transformed it to the left because that's a negative 2. From here, I am going up 3 because that's what it's telling here. It's we need to go up 3. So from here, I'm gonna go up 3, 1, 2, and 3. And it says here that it is supposed to open down. So then I am going to open the absolute value graph downward. So then I am going to trace the graph right now. So let's trace this graph here. So this is the graph right here. So I will retrace it. So this is our translated graph. And the equation for this graph is y equals negative of the absolute value of x plus 2 plus 3. Now notice that the vertex that we have here is negative 2 and 3, and that represents the h and the k. So negative 2 is the h, the k is positive 3. Okay, at this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're on the second example here. Again, there is a fastest way to determine the h. Our h here is we switch this, so the h was actually positive 3. And so this is telling us that we are moving 3 places to the right since it is positive. And we have a positive 4 here. It's telling us that we are moving 4 steps up. This a here is telling us that this opens down since that is negative. So what we do here is from the parent graph that is sitting on the point of origin, I am going to move this graph 3 places to the right, 1, 2, and 3, and then I will move this graph 4 steps up, 1, 2, 3, and 4. So the graph is gonna sit here. So that would be on this spot right there. So that's a 3, and 3 places to the right and 4 places up. Okay, so I'm going to trace this graph, and it's facing downward because again the a value that we got was negative. So this is our graph. It is sitting on that vertex right there. And so I can label this graph as y is equal to the negative absolute value of x minus 3 plus 4. Notice that the vertex is on it's in positive 3 and positive 4. So positive 3, positive 4. Did you get the same graph as this? Good. Perfect. Now let's move on to the third one right here. So again, our h here is we switch this, so h is actually negative 1. And so this is telling us that we are moving 1 step to the left, and this is a negative 6. It's telling us that we are moving 6 steps down, and since that is a positive, this is telling us that this opens up. So from the point of origin, right there, so let me let's translate it. So again, in all of the equations that we have, the 3 equations, they all have an a of either positive 1 or negative 1. So let's transform this. That's 1 to the left, 1 left, and then 6 down, 1, 2, 3, 4, 5, 6. So this is where the graph is gonna sit. So, and this is the graph right here. Let me trace this. So the equation for this graph is, that would be y equals the absolute value of x plus 1 minus 6. Notice that our vertex is located at negative 1, and then negative 1 and negative 6. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!